Hello, guys. Happy Thursday. So, today you can see on the right hand side, you're going to need your workbooks to go through this slide presentation with me today. Then at the end, you're going to complete a Google form, end of lesson check in. And then you have to complete 15 minutes of your iReady path. If you've already reached your 60 minutes, yay, you're done for the week. If not, remember you need to have a total of 60 minutes completed by Friday afternoon. All right, so here's our would you rather from the other day. You can see that in our pie chart, 73% of you who completed it said that you would rather have the ability to decide when it will rain versus growing flowers. And if you kind of look at this and we break this up into equal parts, we can kind of estimate that, well, three-fourths of the students want to have the ability to make it rain, and 27% is about one-fourth of all of the students. And then you can see below, I just included some of the responses that you guys offered. Somebody said, I would like the ability to make flowers pop up wherever they point. They thought it would be fun for pranking people, and they like flowers. Um, Somebody else said rain because sometimes I will be inside and I just hope it would rain. And if I'm doing something outside and I don't want it to rain, I could just make it stop. And then the last person again also decided that they would like rain because they like to be outside, but they also find it kind of calming when you're inside and you can listen to the rain. So, just some feedback that you guys can see. All right, so now let's take a look at our estimation activity for those of you who completed it. Um, you can see that we had the small plate that we were trying to estimate how many cheese balls would fit on there. If I remember correctly, 156 fit on that large plate that's underneath. And so we had to figure out, well, how many could fit on the small plate? So this is the first time I feel like we had somebody hit it exact. So let's take a look. The answer is 91 cheese balls. I feel like our guesses for this were a lot closer than in the past. Sometimes we have some pretty interesting outliers, but most of the guesses were pretty reasonable. And with an exact guess of 91, Paige. So great job with that. All right. So, another reminder that you do need your workbook. So, if you haven't gotten that out, now would be a good time to go grab it. We are continuing with our geometry standard, looking at attributes, categories, and subcategories of two-dimensional shapes. Today, we're going to be refining our understanding of subcategories and continuing to grow that knowledge because after lesson 28, we go into lesson 29 where we're continuing to work with the hierarchy and the subcategories of shapes. So we're going to be really working with shapes for a good another week or so. All right. So once again, I'm asking you to turn to page 581 in your workbooks. We're going to do some problems together. I'm going to be asking you to push pause, try the problems out, come back and check your work. And then at the end, you will be completing a Google form. So on page 581, we are going to go over our vocabulary first. You can see attribute again, characteristics. We're usually looking at the types of sides, whether they're parallel or perpendicular, the lengths of sides, are they congruent? The number of sides, the number of angles, the type of angles. Do we have all right? Do we have acute and obtuse? And then we go from categories to subcategories. Remember, categories are broad, general descriptions. And then those subcategories, as you get lower within your tree diagram, or smaller ovals within your Venn diagram, those become more specific subcategories. All right. So here you have your cheat sheet of all of our quadrilaterals. So you can see a trapezoid only has one set of parallel sides. So again, a quadrilateral is any polygon with four sides and four angles. And a trapezoid, you can see that the top and the bottom will never touch, so there's that one set. But the left and the right, if they were to continue on and on and on, they would eventually intersect. A parallelogram has two sides that are parallel and opposite sides that are equal or congruent to each other. So a parallelogram is more of a general description, and then all of these become more specific as we go through them. So again, you have two sides that are congruent to each other and opposite sides are parallel. A rhombus has all of the same characteristics of a parallelogram. You can see two pairs of parallel sides, but also four sides of equal length. And if I have four sides of equal length, that still means that I have two pairs of equal length because the top is the same as the bottom, the left is the same as the right. A rectangle is a parallelogram because it has the two pairs of parallel sides. It has the two pairs of sides that are of equal length. So you can see that it has all of the rules of a parallelogram also. But what's different is that it also has to have four right angles. So a rectangle is a subcategory of a parallelogram because it meets all the rules of a parallelogram, but then also is more specific. A square is a subcategory of a rectangle, of a rhombus, and of a parallelogram. A square meets all the rules for these other shapes as well. Two pairs of parallel sides, four sides of equal length. You can see that as a rhombus, as well as four right angles, which is what makes it also a rectangle. So a square is the most specific subcategory we have when we're talking about our quadrilaterals. All right. So on page 581, we're going to be looking at question number 1 here. And you can see that we have a Venn diagram at the top because we are using ovals. So again, your largest oval is going to be your most general term. And then as it gets smaller, they become subcategories. Now, if I'm working from squares to rhombus to parallelogram, a square has to have all the attributes of a rhombus because it's inside the rhombus oval. A square is also going to have all of the attributes of a parallelogram because it's inside the parallelogram. A rhombus is going to have all the attributes of a parallelogram. So as I work from smaller oval to bigger oval, they're going to have to share the same attributes. But as I go from larger oval to smaller oval, they would share only some of the same attributes. Not all parallelograms are going to be rhombuses. Some of them are. Not all rhombuses are going to be squares, but some of them are. So I want you to go ahead and push pause on the video, and I want you to answer these questions A, B, and C. It says complete each statement using all or some to make the statement true. So go ahead, read the statement to yourself, and then I want you to come back and push play, and we'll go over it. All right, so hopefully you used my trick with the yellow arrows at the top where they say some and all to help you fill in these blanks. So squares have blank of the attributes of rhombuses. So we know that squares are the most specific. They're the smallest oval. So squares, in order to be inside the rhombus oval, they have to have all the same attributes. And again, in order to be a rhombus, you just have to have four equal sides, be a four-sided figure. Opposite sides are parallel. All right, so now let's look at B. B says rhombuses have blank of the attributes of squares. So let's go ahead and think about this. I'm sorry, of parallelograms. Let me read B. It says rhombuses have blank of the attributes of parallelograms. So because a rhombus is inside the parallelogram, and when you go and you look back at this chart, we were saying in order to be a rhombus, it meets the rules of a parallelogram. So rhombuses have all of the attributes of a parallelogram. And then the last one, parallelograms have blank of the attributes of rhombuses. Well, not all parallelograms are going to be a rhombus. For example, when I look at this here is a parallelogram because it has parallel sides and opposite sides are equal. But not all the sides are equal, so I can't put this in this category. So they share some of the attributes. And some of those attributes that they share, they're four-sided figures. Opposite sides are parallel. All right. So part 2 on this page says, name 2 attributes that squares and rhombuses always share. Name an attribute they only sometimes share. So let's take a look at this list. So you're going to look at these 2 bullets here, and you're going to look at these 3 bullet points here. Now, the ones that they share would be the ones that are in both columns. The one that they don't share would be the one that's the third one in the square column that you don't see here. So go ahead, push pause on the video, and go ahead and answer this under number 2. All right. So hopefully this was pretty easy for you just by using our little chart. And let's take a look. All right. So you can see, well, both rhombuses and squares always have 4 sides of equal length. And I can see that bullet point here, and I can see that bullet point here. And then they also have 2 pairs of parallel sides. Well, I can see that top bullet point under rhombus and that top one under square. So those are the ones that they have in common. Now, the one that would be different is squares always have right angles. Some rhombuses have right angles, but not all of them. So that's really important to note. All right. So let's go ahead and take a look at this problem here. I'm going to ask you to draw a tree diagram to show the hierarchy of the terms below. You can either do this in your notebook, or if you have in your workbook a spare spot, I want you to try and draw this yourself first. So we are going to take a look at these terms: parallelograms, polygons, quadrilaterals, and squares. And remember, the top part of the tree is the most general, and as we go down, it becomes more specific. So again, push pause on the video, go ahead and try and create your own tree diagram. What is the most general of these terms? What is the most specific of these terms? And then when you come back, we'll go over it. All right, so let's take a look. Parallelograms, polygons, quadrilaterals, and squares. So the most specific of these terms, the thing that should go at the very top is going to be polygons. The reason why is because a polygon refers to any shape that is just made up of straight lines and is a closed figure. So it could be a triangle, a quadrilateral, it could be a shape with 8 sides, which is an octagon. It could be a shape with 5 sides, that's a pentagon. So that is the most general. Now, when I look at my remaining 3 terms, I see that squares, quadrilaterals, and parallelograms. Well, the next term that's going to come is going to be quadrilaterals, because that talks about any shape that has 4 sides. So again, a polygon just talks about any shape that is made up of straight sides and is a closed figure. Quadrilaterals is talking about any 4-sided shape. So you can see how we got a little bit more specific. The next term that we are going to use is parallelograms. Why? Because squares are parallelograms. Parallelograms just say that you need to have 2 sides that are, or excuse me, 2 sets that are parallel. So the top will never touch the bottom, the left will never touch the right, and opposite sides are equal. And then finally, our last one is going to be a square. So, a square. Because it is the most specific of this list of terms. So now let's go ahead and take a look. Write all, some, or no to make each statement true. Parallelograms have two pairs of parallel sides. Well, we know that anything to be considered a parallelogram, they all have to have two pairs of parallel sides. Quadrilaterals have two pairs of parallel sides. Does every quadrilateral have two pairs? Well, let's go back and look at our list real quick, and you can see, well, wait a second. This first one here says only one set of parallel sides. And it's possible to draw a quadrilateral with no parallel sides. So when we go back to this here, this would be some. Some quadrilaterals do, but not all of them do. So you can see with this lesson, you really have to think deeper about what's going on with each of these shapes. All right. So I know you already have your workbooks out, so we're just going to flip to page 583 now, and we are going to take a look at some more problems. So on page 583, it says, a regular polygon has all sides of equal length and equal angles of equal measure. Which shapes below are subcategories of regular polygons? So again, a regular polygon is any shape, or excuse me, any polygon that has all the sides that are exactly the same length, as well as angles that equal the exact same amount. So we know that squares have four equal sides, and we know that all of their angles are right angles. Pentagons, the definition of a pentagon is any five-sided shape. Does that sound very specific to be a subcategory right now? Equilateral triangles, triangles that have three equal sides, as well as three equal acute angles. A hexagon is a six-sided polygon. So, now that I've explained those terms, maybe you are already thinking which ones could be a subcategory of regular polygons. You have some ideas, so let's see if you're right. Squares and equilateral triangles. They both have all sides of equal length and all angles of equal measure. Now, I want you to understand that some pentagons can be regular polygons, as well as some hexagons. But we were looking to be very specific here. And you can see that squares and equilateral triangles, what we know about them is that specifically to be called those, you need to have equal sides and equal angles. All right, so here we have number 2 on page 583. And you can see that a tree diagram can use two lines to show subcategories that do not overlap. Jose drew these two diagrams to show how categories of triangles are related. Are his diagrams correct? Are his diagrams correct? And explain. So let's take a look at this because we're going to do this one together. So you know that you have your broad category of triangles, three-sided shapes. Then if I wanted to classify them by their sides, I can break that up into scalene or isosceles. So not all tree diagrams have to go just in a straight line, like our example on this slide here, where they just go straight up and down. Because I can have three sides that are the same, then I can have at least two sides that are the same. And then I can have more specific, where instead of just having at least two sides the same, all three are the same. So you can see kind of how this family tree gets broken down. This is related to the Venn diagram over here because I can see this big outline represents all triangles. And then I can see how there's no overlap here because either I have no sides that are the same Or you can see I have at least two sides that are the same, and then an equilateral triangle is a subcategory of isosceles. That's why it's inside of it. So I just want to show you how we're growing our Venn diagrams, and we're growing our tree diagrams to be able to show more than one branch. So let's take a look at the response here, and please feel free to copy this down so that way you have it in your books to refer to. So this is just a possible explanation. You can see that equilateral triangles are a subcategory of isosceles triangles, and we know that because they have at least two equal sides. You see that subcategory because equilateral triangles hanging off of the isosceles branch, or over here you can see that because it's inside this oval here. Scalene triangles have all sides of different lengths, so they cannot be isosceles or equilateral, so that's why they're off by themselves. So if you have questions about this, now would be a good time maybe to just go back a minute or two in the video, rewatch it, or for you to shoot me an email and ask me your specific questions so that way I can address it before you move on. All right. So here we're going to look at this diagram, and it says Jake makes a tree diagram to show a hierarchy of polygons. So this would be over here, the most general all the way down to the most specific. Explain why Jake's tree diagram is not correct. And then let's talk about the changes he needs. So I'm already telling you that he's wrong. So I want you to push pause on the video, and I want you to try and jot down your answers to number 4 about what's going on here. All right, so let's take a look. So pentagons are not a subcategory of of quadrilaterals, because a pentagon has 5 sides and not 4. So do you guys see how we have polygons and then it breaks off into 4-sided figures? And I can't have a 5-sided figure as a subcategory of a 4-sided figure. The tree diagram should show pentagons as a separate branch. So this is what's new today, is that we should have a separate branch. The rectangle and parallelogram boxes are in the wrong order. Did anybody else pick up on that? That they should be flipped around. Rectangles are a more specific kind of parallelogram. And you can see that it says a rectangle has 4 sides and 2 pairs of parallel sides, like a parallelogram, but it also has 4 right angles. So that's why they need to be flip-flopped. That's really important that you take a look at that. So now we're going to go ahead and draw this the right way. So here you can see this is the incorrect part. So thinking about what is the most general here? Well, in the top box, so go ahead and in this space provided in part B, draw that top box, and that's where you should have your polygons. Okay, it's the most general, talks about any number of side shape as long as it's made up of straight lines and it connects. So now here we have 4-sided figures and 5-sided figures. And you can see that would be the next branch on our tree diagram. So again, you have pentagons coming off by itself because it can't be a subcategory of quadrilaterals. 5-sided shapes, 4-sided shapes. And now we're going to head down to the next one. We have rectangles and parallelograms, and here you would have parallelograms first, and then you would have your rectangle. All right. So again, most specific, extra branches here, and then following it right down. So this one here, we're not going to go over. You're going to see this in your exit ticket for today. Okay. But I just wanted to talk about it real quick. I'm telling you that this is not correct. Okay. And you really have to take a look at these 2 statements and read them carefully. If you need to go back into the video and look at the diagram for quadrilaterals, that could be helpful. But there's some subcategory issue here, so I wanted to remind you of that. So now it's time for you to head on over to your Google form. The link is on the next slide and complete your answers for today. Then hit submit to turn this presentation in. Several of you still have not completed Monday's assignment. It's iReady teacher assigned lesson on two-dimensional shapes. You might want to even watch that before you take your Google form today. But please make sure that you're getting your work done because I don't want you to be overloaded with a lot of makeup work over the weekend. So it's important that you do your assignments every day. All right, if you have any questions, please email me, and I look forward to sending you another video tomorrow. Have a good Thursday.